page 73, we're going to do some reviewing. Lesson 1112, IN1, IN2, and IN3. So on page 73, we've got just a couple of questions. We haven't done all of these yet. A little vocabulary review. So number 2 is one we can look at here. Number 2, a decimal that ends is a or an. So if we look at the word bank up there, and we can see which one this would be. And so that would be a terminating decimal. Terminating decimal is a decimal that ends. Okay? And if we wanted to, we could talk about, they've got a spot for an example here. So an example of a terminating decimal, we could have like 7/10. That would be a terminating decimal. You could have a whole number part, like 4 and 139 thousandths. That would be terminating decimal as well. Next, if we look at number 3, two numbers that have a sum of 0 are, and so that would be additive inverses. Additive inverses. Another term for that, instead of additive inverses, is opposites. Opposites is a little bit easier to work with than additive inverses, but those both mean the same thing basically. So an example of that, we could have -3 and 3. Those would be opposites. If we add those together, -3 plus 3 equals 0. Lesson 1 was on relating integers and their opposites. So if we look at number 1, on a cold winter morning, the temperature was -4 degrees Fahrenheit. By noon, the temperature increased 4 degrees. What was the temperature at noon? So it was -4, and then it increased by 4. What was the temperature at noon? And so that would be basically the temperature is -4, increased by 4. It's like -4 plus 4. Those are opposites, and so we add those together, we get 0. So that would be 0 degrees Fahrenheit at noon. Number 2, Audrey deposits $27 in her account. So deposits is putting money into the bank. Then she makes 2 withdrawals, one for $15 and one for $12. Withdrawal is taking money out of the bank. And the question is, what is the total change in the balance of Audrey's account? So she made a deposit of $27 and withdrawals of $15 and $12. What is the total change in her balance? So one thing we can do is just look at with our deposits. There was only one deposit and it was $27. Our withdrawals, we had withdrawals of $15 and $12. So that's $27 altogether. So if we put $27 in and then we take $27 out, altogether our total change is 0, or $0 if you want to, or you can say there's no change. And a way of looking at this, you could say 27 plus -27, or you could back it up, you could say 27 plus -15 plus -12. It might be easier just to look at what do we have in deposits and what do we have in withdrawals, and then in this case they just cancel each other out. Lesson 1-2 is on understanding rational numbers. So a couple definitions here. We've got terminating decimals end with repeating zeros, or basically we work it out and it gets to a point where it just stops. Repeating decimal has a never-ending pattern of the same digit over and over, like 0.55555 and so on. That's a repeating decimal. So one of the things they can have us do on this first part here, they're asking which fractions have a decimal equivalent. That's a repeating decimal. Select all that apply. Now we could work these all out by hand. That would take a little bit of time. So rather than doing that, we can use calculators. Remember, the fraction bar means divide. So for the first one, 13/65, we could take 13 divided by 65. Now on your calculator, when you type it in, you're going to just type in 13 divided by 65. It's basically just taking the fraction and smushing it sideways because there's not enough room to write the fraction all on one line, or all vertically, I should say. So it just smushes it sideways. If you were doing this by hand, you would be taking 13 divided by 65. The 13 would go on the inside, numerator on the inside when you divide. But on your calculator, it's just kind of smushing it sideways instead of writing it vertically. So if we divide that out, we should get 2/10, and that just ends. That's a terminating decimal, so it is not repeating. If we look at the next one over, we've got 141 over 47. If you divide that out, then you will get 3, and that's not a repeating decimal. There's not even a decimal there to begin with, so obviously not a repeating decimal. 11/12. So this comes out as 0.916. You're going to have a bunch of 6's, and then at the end there's going to be a 7. The 7 at the end is just the calculator rounding that off. So even though it goes to a 7, it actually doesn't really go to a 7. That 6 part is repeating, and so that is a repeating decimal. And finally, 19/3. So this would be 6.3 repeating, and so that would be a repeating decimal. Number 2, Greg bought 19 and 11/16 gallons of gas. What decimal should the meter on the gas pump read? So the gas pumps have decimals, not fractions, for how much gas you get. So we can divide that out. That's going to come out as 19.6875. Okay. Now again, if we were doing this by hand, we know the 19 is going to be there. It's going to be 19 point something. And then you could just do 11 divided by 16, and we could work that out. Okay. Again, the plan here, we'll probably use calculator that you can be able to just divide it out, and so we can get through the problems a little bit quicker that way. Number 3, what is the decimal equivalent of each rational number? So more changing to decimals here. So for part A, that comes out as a repeating decimal. It's 0.818181 and so on, so we can put a bar above the 8 and the 1. If you want to put a 0 before the decimal point, you can. Either way would be okay. Part B is 8/10. So negative 17/5 comes out as negative 3.4. And part D, that one comes out as 0.5 repeating, or 0.5 repeating. Again, the calculator is going to put a 6 at the end. That's just rounding that last digit up is all that's happening there. Lesson IN1 was on prime factorization, least common multiple, and greatest common factor. So first, let's look at finding the prime factorization of 42. So you might remember, for finding prime factorization, one way of doing this is to do a factor tree. Factor tree, we're trying to break it down into its prime factors. So breaking 42 down, 42 is 6 times 7 is one way of doing that. If you did something else, as long as it multiplies together to get 42, you're okay. The 6 can be broken down as 3 times 2. Both of those are prime, and the 7 was prime. Now we've done a factor tree, we've not written our prime factorization yet. So our prime factorization, we've got to write this out, the prime factors we found. 2 times 3 times 7 If you put it in a different order, it's not wrong. It's just usually they start with the lowest factors and work their way up from there. So this would be our prime factorization. Another thing we did in this lesson was find the greatest common factor, also known as the GCF. So here, if we find the greatest common factor of 22 and 55, if you remember, for greatest common factor, we're going to get the common factors. We can circle the common factors in a different color, and then the factors that we circled get multiplied together. So if we just break these down, 22 breaks down as 2 times 11. Both of those are prime. 55 breaks down as 5 times 11. Both of those are prime. And now we're looking for common factors. So they both have an 11 in common, and that's all. So our greatest common factor would be 11. And so that means both of those, the biggest number we could divide both those by evenly would be 11. Remember, there's also word problems they could have us do, where we would have to decide, do I need greatest common factor or least common multiple? The other thing we did in that section was finding least common multiple, or LCM. So least common multiples, we're just going to list out multiples of these numbers is one option, and we can figure out what's the first multiple they have in common. So we're going to be listing out multiples of 4 and multiples of 9, and try and get one that matches up here. So we list these out. Multiples of 4, we got 4, 8, 12, 16, 20, 24. At some point, if you want to start on the other one, just to make sure you don't have anything in common, 9s, we could do 9, 18, 27. I still don't see anything in common. We go back to the 4s. Next multiple of 4 would be 28, 32, 36. Next multiple of 9 would be 36. So there it is. Our least common multiple is 36. You might have had an idea of that from the start. Again, think about if these were denominators, our least common denominator would be 36. This was our worst case scenario. If you end up having to multiply the two numbers together, 4 times 9 is 36. That's the highest possible least common multiple we can have, and that's what we had here. So that just gives you an idea, just to make sure you don't, if you mess up somewhere along the way, that you don't keep going and find something that's actually bigger than what you need it to be. Lesson IN2, a big topic on this section was whether something's rational or irrational. So we've got some numbers here, and we're just going to say whether they would be rational or irrational. $11 would be rational. Rational means we can write it as a fraction with two integers. Basically, irrational has decimals that keep going and don't repeat. If it doesn't have that, then it's going to be rational. That's the easiest way of looking at it. Square root of 15 doesn't come out evenly, so that would be irrational. The next one, negative 14, is rational. 5/7 is rational. 9/4 is rational. That last one, it's got a pattern to it, but it's not the same thing, so it's not repeating, so that would be irrational. It wasn't one of the choices here, but if you would have had something, let's say like 0.7 repeating, that would be rational. Repeating decimals are rational. That could be written as 7/9. Lesson IN3, one of the main things we talked about is ordering numbers from least to greatest. So what you might want to do for these is get these as decimals, and then we can put them in order. So 2 1/4 you might know as 2.25. Square root of 5, we could use our calculator to get an approximation for that. So that comes out to about 2.236. And now we can put these in order least to greatest. Notice this one number is negative. So negative 2.4 would be the lowest number. So the next lowest, if you look, these are both really close. If we go to the hundredth spot, we can see 2.236 is lower. Go back to the original number they gave you, which was square root of 5. And then next would be 2.25, which originally was 2 1/4. And then finally our biggest number here is 2 5/10, 2.5. So this gives you an idea of how to look at some things in lessons 1-1, 1-2, IN1, IN2, and IN3. Remember, you can look at your website. It used to be Pearson Realize, now SavistRealize.com, to get some more practice. Have a good day.